Hello, welcome back to another episode of Measurement in a Minute. I'm your host, 𝗦𝗧𝗔𝗬𝗘 with Lakeside Process Controls. And in today's episode, we're continuing our discussion around Rosemount's magnetic flow meter technologies. In particular, we're talking about slurry applications for mag meters. Now, if you recall from a couple of videos back, we said slurry applications are a great target for mag meters because they do not obstruct the piping. So what we can do is we can line the mag meter with various liners and electrode materials to protect it from slurry. So they work very well in these applications, pending its conductive fluid. The challenge is, what is a slurry? It's primarily a liquid with some sort of solid in it, maybe mined ore, pulp stock, sand, concrete, particulate. And so when you have really two-phase flow conditions, that can create instability in a measurement, especially as you have a general erosion of these solids in that mag meter. And so it's not uncommon to see a raw signal out from a mag meter look like this, right? A high degree of variance. And from this, you might be asking, well, how am I supposed to get repeatable and accurate flow measurement? And that is going to be answered in a later video. Today's video is focused on, where does all this noise come from? Okay, and it comes from three noise profiles which combine together. So the first is called 1/f noise, and it might be the hardest to kind of intuit and understand. So let's look at a plot to better understand this. So if the x-axis is frequency and the y-axis is amplitude, you'll see it has a 1/f relationship, or a 1/frequency relationship, where the amplitude is decreasing with an increasing frequency. Now, why does this matter? Because mag meters typically operate on the lower end of this frequency range, where we see the highest levels of noise according to this 1/f relationship. So we need to overcome that to have an accurate and repeatable measurement. The next noise profile is spike noise. This is pretty obvious and easy to understand when you see it. So we have particulate or solids moving through this liquid and sometimes coming in contact with the electrode and quite literally spiking in the reading. So these are pretty easy to see where they are, especially compared to the regular flow signal. And they're also pretty easy to overcome and correct for because it's just for an instant and then it goes away. The last noise profile is white noise, which most people understand. This is going to be an even or consistent amplitude across all of the frequency range. So when you combine all three of these noise profiles together, this is what we must overcome in a mag meter to have an accurate and repeatable measurement. Should you have any questions about Rosemount's magnetic flow meters or any other of our products, please reach out using the QR code to my left. Thanks and have a great day.